Welcome to The Explainer. Today, we are cracking the code on poisons. We're going to dive into how forensic experts classify these, deadly substances, and we're going to reveal the surprisingly thin line that separates a life-saving medicine from a lethal toxin. Trust me, by the end of this, you will never look at your medicine cabinet the same way again. So let's start with a really big question. Is a substance a medicine, or is it a poison? Seems simple, right? Black and white? But oh, the answer is so much more complex and, honestly, surprising than you'd think. This is actually the central puzzle that toxicologists have to solve every single day. You see, the line between healing and harming is just incredibly thin. It's not really about the substance itself. It comes down to two absolutely critical factors. The dose, how much is used, and the intent. What was it used for? This idea, right here, is the core principle that governs the entire field of toxicology. Okay, so let's get the formal definition on the table. A poison is basically any substance, solid, liquid, or gas, that can harm or kill a living thing. This forces us to kind of shift our thinking away from labeling chemicals as just good or bad. Instead, we have to focus entirely on cause and effect. What does it do? And here's where it gets really mind-bending. Almost anything can be a poison if the dose is high enough. I mean, even things we need to live, like water or salt, can become lethal in extreme amounts. It just goes to show you that fundamental rule of toxicology. Dose and context are absolutely everything. When we hear the word poisoning, our minds immediately jump to spy thrillers, right? Cloak and dagger assassinations. But the reality is, it's far more common, and often, tragically, a lot more mundane than that. Sure, criminal poisoning grabs the headlines, but it's really just one small piece of a much larger puzzle. The vast majority of poisonings are actually accidental. We're talking about medication mix-ups, accidental overdoses, and even things we rarely think about, like animal bites or just contaminated food. In fact, a huge percentage of these poisonings happen right where we feel safest, in our own homes. We're talking about the cleaning solutions under your sink, the fuel in the garage, everyday cosmetics and glues, and yep, even some of those common houseplants. So, okay, with thousands upon thousands of potential poisons out there, everything from household cleaners to exotic venoms, how in the world do forensic toxicologists even begin their investigation? Where do you even start when the suspect could be almost anything? Well, to create order out of all that chaos, they use a brilliant two-pronged approach. First, they classify a poison by its mode of action. That's what it does to the body. And second, they figure out its chemical nature, which is what the poison actually is. This dual approach is the key to their entire investigation. All right, let's unpack that first one, the mode of action. By focusing first on the poison's effects, the symptoms, the physical damage, investigators can dramatically narrow down the massive field of potential suspects. It's like detective work. The first category here is the corrosives. These are the absolute brutes of the poison world. They don't mess around with subtle mechanisms. They cause immediate, direct, visible destruction to any tissue they touch. Seriously, think of them as a chemical demolition crew. And the examples are pretty much what you'd expect. Really powerful industrial chemicals. We're talking strong acids, like sulfuric acid, and strong bases, or alkalis, like caustic soda. These are substances that are just incredibly destructive on contact. Next up, we have the irritants. Now, unlike corrosives, they don't cause that same level of immediate tissue destruction. Instead, they provoke this violent reaction from the body itself, causing severe pain, vomiting, inflammation. They're like little riot instigators inside the system. And this category is unbelievably diverse. An irritant could be an inorganic heavy metal like arsenic, or an organic toxin from something like castor beans or snake venom. Or it could even be something mechanical like powdered glass, which literally just causes damage by scraping things up. And finally, in this classification, we get to the systematics. These are the covert spies of the poison world. They're sneaky. They get absorbed into the bloodstream, they travel through the body, and they carry out a very specific mission, attacking a particular organ or system, like the heart or the brain. So, check this out. You have neurotoxins, like opioids, that go right for the nervous system. Then there are cardiac poisons, like nicotine, that attack the cardiovascular system. And then you have asphyxiants, like carbon monoxide, which shut down the respiratory system. Each one has a precise, deadly target. So, once an investigator has a pretty good idea of what a poison did based on its mode of action, they then have to figure out what exactly it is. And that's where the second classification method comes in. This happens in the lab. This next part of the classification is all about chemistry, pure and simple. It groups poisons based on their molecular structure and their properties. This is basically the chemical fingerprint the lab needs to figure out exactly which tests they need to run to get a definitive match. And you can see from this chart just how detailed this whole process is. Toxicologists can identify a substance based on whether it's a gas, a volatile compound, a heavy metal, a plant-based alkaloid, you name it. This chemical fingerprinting lets them pinpoint the exact culprit out of thousands of possibilities. So, after going through how forensic experts define these things and then meticulously classify them by both their actions and their chemical identity, what's the big idea here? What should we really walk away with? It really all comes back to this one idea, which is summed up perfectly in this quote. A medicine in a toxic dose is a poison, and a poison in a small dose may be a medicine. That says it all, doesn't it? The line isn't fixed. It's defined entirely by the dose and the context. So in the end, poison isn't some fixed chemical label. It's really a concept that's defined by the situation. It's not just about what a substance is. It's about what it does, how much of it there is, and how it's being used. And this way of thinking, it doesn't just apply to crime scenes. It changes how you see everything. The warning label on a bottle of aspirin, the instructions on a can of bleach, even the plants growing in your garden. So after seeing the world through the eyes of a toxicologist for a little while, what will you see differently now?